So as compelling as the case is for why coal, let's talk about how coal. And then you have to ask yourself, how? And the answer is, we have to do it cleanly. More clean coal is essential for satisfying a number of our energy needs. And we need to continue increasing our use of coal, but we must do more to achieve the parallel sustainable goal of a cleaner environment. We've had a very good track record that is getting better. When you consider that coal used for electricity generation has tripled since 1970, while at the same time the key criteria emissions have been reduced by more than 40%. As our GDP increases, our population grows, our electricity use has increased, our emissions have continued to decline. Longer term, we remain bullish on BTU conversion technologies that can turn coal into natural gas, transportation fuels, and other energy sources. Whether it's the advent of plug-in electrics, high gas prices that LNG isn't fixing, or ethanol that needs coal for conversion, or $100 oil. Interest in these projects also continues to grow, creating ready-made markets. The U.S. Department of Defense has a goal of procuring half of its fuel from domestic synthetic sources by 2016. And just Monday, the Air Force announced an ambitious plan to develop its own privately financed coal-to-liquids plant in Montana, among the first of its kind in the nation. Proven technology can transform coal into natural gas, diesel, and jet fuel. The process starts with coal gasification, conversion process where oxygen, heat, pressure, and the coal are converted into a synthesis gas composed primarily of two streams, hydrogen and carbon monoxide. From there, cleanup processes will remove sulfur, the particulates, and the back-end technology creates either the gas, the diesel fuel, or the jet fuel. And in coal to synthetic natural gas, the gas that is produced is interchangeable with pipeline quality natural gas. Now, there's some interesting facts associated with BTU conversion. Coal to liquids with carbon capture can produce ultra-low sulfur fuels at the same rate of CO2 emissions as imported oil. Coal to gas creates a nearly pure stream of CO2 that can be captured and stored, so that synthetic natural gas from coal with carbon storage has a better footprint than liquefied natural gas. And even today's new supercritical technology coal plants contribute to low carbon utilization with a 15% lower carbon intensity than anything that's in production today. And then, of course, we have projects like GreenGen in China, which ultimately would have near zero emissions utilizing full carbon capture. The technology advances for a carbon-free future are being made on a number of fronts. These include scrubbing and storing carbon in oil fields, saline aquifers, and beneath the ocean floor, and geology that offers both ample space and permanence. Carbon dioxide for greater enhanced oil recovery, for instance, is a process used by the petroleum industry for over 30 years. Now, this could lead to a production of another 2 to 3 million barrels of oil today in the United States alone if CO2 was captured and used for enhanced oil recovery. There are other promising technology paths, including reducing carbon dioxide in an oxygen-rich environment during the combustion or using scrubbing agents for CO2 removal post-combustion. Once the carbon dioxide stream is separated, it's compressed, making it easier and less costly to transport. All technologies that we've been doing for 3 decades. And ultimately, it's injected deep underground into the same caverns that have safely stored the methane, the oil, or the natural gas for centuries. Over time, the CO2 binds with the host rock matrix. Now, the world has ample room for carbon storage. And just as America was blessed with good geology for coal, we are also blessed with good geology for carbon storage. we could sequester CO2 for the next century and wouldn't even use 10% of the potential geology that's suitable for storage. We have, in fact, enough storage for hundreds of years of emissions from our U.S. electricity fleet. Our challenge as a nation is to commercially prove out the carbon technologies on a broad scale, beyond just enhanced oil recovery, because the United States doesn't know how much it costs to store CO2 today, nor does anyone else. Is it going to be $30 a ton of CO2 or $80 a ton, or more, or less? We just do not know. So advancing clean carbon technologies is an industry priority, and it also has strong bipartisan support. Congress recently earmarked an additional $440 million in funding, annual funding, for carbon capture and storage demonstration projects in the recent energy bill. Now, Peabody is a leader in developing clean coal solutions. We're advancing signature initiatives to commercialize clean coal technologies through GreenGen in China, the Coal 21 Fund in Australia, and through our longstanding support of Vision 21 and FutureGen in the United States. Each of these initiatives seeks to commercialize near-zero emissions with carbon storage. We're also a major sponsor of the Power Systems Development Facility in Wilsonville, Alabama. It's the nation's premier laboratory for testing coal gasification technology in partnership with the U.S. Department of Energy and Southern Company. I'm proud to say that Peabody is also the only non-Chinese equity partner in GreenGen, a commercial prototype for near-zero emissions in carbon storage being constructed southeast of Beijing. The first phase of GreenGen will be online as early as next year and will ultimately include about 650 megawatts of clean generation with hydrogen production. And eventually CO2 will be used for enhanced oil recovery in China. Peabody is also investing in companies that are advancing emerging technologies for coal gasification. One of our recent investments is in Great Point Energy out of Cambridge. Great Point has proprietary blue gas technology that converts coal into clean substitute natural gas while enabling carbon storage. They've successfully tested a pilot and are engineering the first commercial project. Peabody and Great Point are looking at the potential for a joint coal gasification project using Peabody reserves and property. So hopefully when you see that when you add up why coal and how coal, the new face of coal is truly what we would call the green alternative. There are a variety of opportunities for venture capital, particularly in startups like Great Point, that are commercializing emerging technologies for clean coal products with carbon storage. Some firms are even advancing carbon-hungry algae that readily consume carbon dioxide and other power plant emissions, oxygenating the air during photosynthesis. Even Tesla's electric car initiatives will result in great efficiency gains in the transportation sector. Beyond many of the core initiatives I've highlighted, Peabody is developing a strategic technology program to advance emerging clean coal technologies through venture capital and equity partnerships. We also continue progress with our carbon management initiatives internally, reducing our greenhouse gas intensity throughout our operations. So I want to thank you for letting me be here today to share with you why I believe why coal and how coal really do lead to green coal. Thank you very much.